Well, hello, 7th grade peoples, L90. Oh, sets. So we've talked about before, importance of lessons to our future. This one ranks kind of low. However, there are elements of it that actually come up on your HSPT. So, a lot of terminology, some new symbols. You're going to be fine. I'm not worried about you. Let's first define what a set is. A set is a collection of elements or members. These are obviously usually values, they're numbers, but they don't have to be. So we can look at sets that don't have those things, but we do properly refer to things in sets as elements or members. I know you're familiar with sets. You've been seeing them most of your math life with me. Here's a set, and I'm going to give you a moment to determine what that set represents. Boom, sticker. Nicely done. This represents the set of whole numbers. Now, because it represents the set of whole numbers, we realize we could never write all of those. And so what you'll see is we'll write enough to establish what set it is, such as 0, 1, 2, 3. Then we'll put a comma, and then the dot. Anybody remember what the dot is? Yeah, there you go. Nicely done. Another sticker. It's called an ellipses. That's ELLIPSIS. And they're shown to represent that this set goes on and on forever, essentially. Now, we can have a set that would start with ellipses, something like this, where we'd open up some braces and go dot, comma. Then we'd put our values, -3, -2, -1, 0, 1, 2, and that's probably enough to establish the set. And so I'll put a comma, then I put a dot, the ellipses, and I close that. Can anybody guess what that would be? Yes? Nicely done. Integers, the set of integers. So notice we can have ellipses at the start and at the end. It depends on the set, really. As you can see represented here, we clearly use braces to describe sets in a particular kind of way. So braces are important to it all, obviously. Let's press on. So there's something called set notation. Actually, your next year's book refers to it as roster notation, and there's another type of notation called set builder. So it kind of bothers me that Saxon uses set notation, because next year we're going to have to talk about something called set builder notation, and that's different than roster. But roster notation is the type that you know, where we basically use braces. So here they'd be asking us or directing us to use set notation to denote the set of even integers. So again, we know that that would go on forever, but not at the start. So actually at the start, because if you think about it, this is sometimes a confusing idea to people. Are negative numbers potentially even? Yeah, of course. Because if you were going to count down from even numbers like 10, 8, 6, 4, 2, 0, where would you go from there? You'd definitely go to -2. So we're going to start with an ellipses, put a comma, and then we'll start with -4. We'll go -2, 0, 2, 4. Usually about 5 or 6 elements or members is enough to establish the set. We'll dot that, ellipses, and we followed their direction, so we're going to put a box around it. Yeah, pretty standard stuff. Mostly they've asked you to kind of interpret sets and name the next value, or maybe even name what set it represented. Now they might be asking you to create those sets in this kind of language. Use set notation to denote set of even integers. Here's a new symbol. Anybody know? Kind of looks like an E. Good. Excellent. Okay, good. Yes, this means, and I'm putting it in quotes because this is how we would say it, is an element of. Remember what I talked about, those things in a set are called elements or members. So this is an element of, and I bet you can guess what this would be, quite simply, is not an element of. And the capitals that's my own thing. You don't have to capitalize. You shouldn't capitalize it. In fact, unless you're going to say things like is not an element of, this is how we say these things, so people probably wouldn't even know. You might go, well, how would these work? Well, it might work something like this, where I had, let's say, the set of whole numbers, right? And so then I could ask you questions about the set of whole numbers and say, what about 4? And could I make a statement about that? Is 4 not an element of whole numbers, or 4 is an element? And I believe that 4 is an element of the whole numbers. So I would put that symbol, 4 is an element of, and then I'd just say the set of whole numbers. Nice and simple sort of ideas, right? If they ask me about 2.5, well, 2.5 is not a whole number. So in that case, I'd say 2.5 is not an element of the set of whole numbers. So they're just basically going to kind of ask you to interpret and use new symbols such as is an element of or is not an element of. And let's try this element thing with a set of rational numbers. There's an ABC choice, so I'm going to give you just a few seconds to jot down what you think. Obviously, jot it down lightly in pencil. You might be wrong. And then I'll begin the revelation. All right, that should be enough time for you. So if we consider the set of rational numbers, we do know that 2 is considered a rational number. So we clearly make the statement that 2 is an element of, and then we could put in there rational numbers. We could kind of put that in that set notation using braces. What did you say for this next one? I hope you said this. 1/2 is an element of the set of rational numbers, which could be written in that. Then we look at the square root of 2. Remember, rational numbers in radical form, or if it's a non-perfect square, then it's not considered a rational number. Therefore, we would say that rad 2 is not an element of the rational numbers. Rat numbers. The rat numbers. Yeah. Hey, there's more. Check this out. They might ask you to graph something on a line. And you go, well, that's not too difficult. Yeah, I know. It's not. It's just they're exploring a bunch of ideas in here. So the set of integers. So obviously what we'd want to do, we could never graph them all. So let's get a line going. We'll put arrows. And then I'm going to drop 0 right in the middle because 0 kind of is that nice dividing force. And then I'll go 1, 2, 3. 1, 2, 3, -1, -2, -3. And then to graph those integers, I would be putting just dots. 0's an integer, 1's an integer, 2's an integer, 3's an integer. Now, does this go on and on? Yeah, and so sometimes you'll see this, where they'll darken in that arrow to say, hey, that goes on forever that way, in that pattern. The same would be said the other way. So -1's clearly an integer, -2's an integer, -3 is an integer. And then, does it go on and on? Yeah, it does. So I'm going to put that kind of darkened in arrow. Right? How about this one? We've got to graph the square root of 1, rad 2, square root of 3, rad 4. So again, let's do that number line. I'm not going to put 0 in the middle this time. I'm going to put 0 here. I'll go 1, and I'll go 2, because I know all of those values fit between that. So let's go with the easy ones first. Let's think about the square root of 1. Well, what is the square root of 1? It's 1. So to graph that, I would put oops, I don't know what happened. Oh, sorry. I would graph a dot there, and I'd name it as the square root of 1. We can also take off the square root of 4 off our list right now, because the square root of 4 exists but at simply 2, right? So I'll just dot, graph, that's called, and I'll put the square root of 4. And then I could just kind of eyeball the square root of 2, and the square root of 3 would land right there. Yeah. All right. There's more exciting stuff. Here's a new symbol. It's not a C, and it doesn't involve a C. So if it looks like a C to you, I'm sorry. It really should kind of be like the element sign without the middle part. But this thing stands for something, and it's called a subset. And a subset exists if an entire set is contained within another set. So we would say something like A is a subset of B. And you might go, what are you talking about? Well, it'd be something like this. Let's say that A was this, I was interested in A subset B. That's how we'd write that. There, it doesn't look much like a C. Make it look like that. So let's say that I had A was the set of whole numbers, right? We know whole numbers to be 0 and the counting numbers, or the natural numbers. And then I said set B was the set of integers. Well, we know the set of integers is the whole numbers and their opposites. So in that case, because every single whole number is within the set of integers, we would simply say A subset B, because A is like encased within B. And we're going to look at that idea a little bit later on. These two are the ones I was referring to in regards to your HSBT. They are used, and I want you to become comfortable with it. So this is a nice, good snapshot for us. The U stands for union. That kind of makes sense. And what union is when the two sets are combined. We do not repeat elements in those sets. The one below it is an upside down U, and that stands for something called intersection. And basically, intersection is where the sets intersect or what they have in common. So if we looked at this situation, let's claim that A is 1, 2, 3. That's the set of A. And B is simply 3, 4, 5. Now, if I'm interested in A union B, well, that would be naming each and every single member or element of both sets. But remember, I don't repeat. So I'd put a brace and I'd say 1, 2, 3. Then remember, I don't repeat elements. So even though the 3 shows up in both, I'm just going to name the element of 3 once. And I go 4, 5, close that set, right? And that would be my answer. However, if I use the same data sets or same sets of A and B, and I ask this question, A intersection B, remember what we're focused on in intersection is what they have in common. In investigating the sets, I could only claim that they have the 3 in common. And so I'd brace out the 3 and then box that up because I'd be done. Now it's getting a little lengthy. There's just a couple more ideas we got to get into. So this next idea is something called an empty set. And basically an empty set, by the language in it, you could tell, means that there's nothing in that set. And I go, well, when would that occur? Well, before I tell you that, these are 2 ways that we can show empty set. One would be to have some open braces, basically a starting brace and a closing brace with nothing in it. That's a way to express empty set. Or, and we don't do both, we do one or the other, there's this method. Kind of a flattened out 0, if you could see. It looks like a 0, but it's flat, like oval-like, and then a line through it. And that simply means empty set. And again, you're like, well, where does that come up? Let me show you. So what if I had the A was 1, 3, and 5, and 7, and B was 2, 4, 6, and 8? And I asked this question, A intersection B. Now remember, intersection is what they have in common. But in looking at these 2 sets, they don't have anything in common. So an appropriate answer would be empty set. So I can show it this way with those open braces, and that could be my answer. Or you also have this option. You could do that flattened 0, the oval 0, put a slash through it, and that could be your answer. But again, no need to do both. It's a little redundant to do both. All right, now we are to the last idea that only takes a couple screens. I'm trying to move along. I know we're at 12:40. I'm moving on. I hope you've been exposed to Venn diagrams. Usually they come up in kind of maybe language arts classes or potentially history classes. They kind of look like this, where there'd be like a circle and maybe an interlocking circle. So they're talking about like, maybe, Roman civilization and what's the other big one? Greek civilization. And what would be in the middle here is what they shared. And Greek and Roman civilization shared quite a bit, right? We could also kind of explore concepts of subset with Venn diagrams by maybe putting a circle within a circle. That would be a subset of. And so let's explore these ideas real quick. So what if I was interested in the intersection of the set of rectangles and rhombuses? Well, I could make one circle. It's moving all around. I'm so sorry about that. I could make one circle my rectangles, and the other circle my rhombuses. I'll make it blue. And you see that there is some space in between where they meet, this green space. Well, where do rectangles and rhombuses meet? We've talked about this before. It's that superhero shape, something called the square. Because remember, squares are basically the elements of a rectangle and the elements of a rhombus smashed together. Yeah? So we could show Venn diagrams in that way. Another thing we could explore is something that might look like this. So what if I said that set A was 1, 2, 3, and set B was the natural numbers? And I'm interested in A intersection B. Now, I'm interested in what we talked about before, where you would name what they have in common, which would simply be 1, 2, 3, because that's what HSPT is going to ask you. However, we could look at Venn diagrams to help us out with this, because if I was to basically make a circle and call that circle B, then I know the set of A exists within B, so I could draw a circle and call that A. And in this case, I'd be showing kind of that concept of the subset, that A is a subset within B. Now, another idea is we could say, let's say the set of A is 2, 4, 6, and the set of B is 1, 3, 5. And once again, they ask me a intersection, oh, I'm sorry, a union B. Well, union is this idea that I'm going to show both of them. I'm going to show everything in those sets. However, in a Venn diagram world, basically that would mean I'd show an A here, because there's nothing in A that's in B, and I'd show a B here, showing that they don't really intersect. So Venn diagrams can help us to visually understand something. That's about its only purpose. Not going to take you far in math, though. Hey, this was lesson 90, and this is coming out for you on Tuesday. You'll be watching this. So you'll just be doing homework 90. Hopefully that makes sense. Sorry, it's one of the longer videos, under 16 minutes, though. I hope you're doing well. Reach out to me whenever you need it. Bye.